This is a tiny hollow cubic display that fits in the palm of my hand. It makes use of a unique and rather exotic display that relies on a beam splitter. A high-resolution screen is then strategically placed beneath it to project the illusion of a holographic 3D display against a transparent backdrop. The result is surreal. The visuals are crisp and appear to float in space, creating a mesmerizing effect. Now you might be wondering, what's the real value of a transparent display? In this video, I demonstrate its utility by creating an optical red dot sight and show how some are even leveraging it to preview intricate 3D printed models. But this is just the tip of the iceberg, because in recent years, monumental strides have been made with tiny pixel technology and extended reality displays, offering us a tantalizing glimpse into a brave new world of immersive experiences. Breakout applications like Tupac Shakur's cameo at Coachella and the unveiling of the Vegas Sphere are redefining our interaction with display technology on the world stage. But the real game changer is just around the corner, and I'm going to show you how to tap into this new wave of innovation like a pro. Now, my journey began like most heroic sagas, with me doom-scrolling the deep recesses of AliExpress until I stumbled upon this gem. And I'll admit, I usually approach such finds with skepticism, wary of the lack of risk assessments and technical documentation. However, living in Florida, where we're no strangers to a disdain for safety measures, I decided to take a chance. This device cost me just shy of $13, and I was genuinely amazed when I powered it on for the first time and witnessed the stunning picture it produced. Best of all, you can build one yourself thanks to its reliance on ESP32 open source componentry. The optical prism in this setup plays a crucial role in creating the holographic illusion. As the software renders the visuals in reverse on the 1.3-inch LCD screen, the beam splitter, a 1x1-inch glass prism, is strategically placed directly on top of the screen. The beam splitter then reflects the reversed image, creating a virtual image that appears to float above the display. This technique is known as the Pepper's ghost illusion, where light is reflected off the surface of the prism, creating a transparent reflection that merges with the background, giving the illusion of a holographic 3D display. This is a simple yet effective way to create a holographic-like effect using optical principles and clever positioning of components. Our device is powered by an ESP32 Pico D4 microcontroller, a compact yet powerful board known for its versatility in IoT projects. This microcontroller is the heart of our setup, coordinating all functions seamlessly. This device also features a micro SD card slot for external storage, allowing you to expand its capabilities and store additional data. A ribbon cable connects the microcontroller board to the 1.3-inch TFT IPS display. This display boasts a resolution of 240 by 240 pixels, ensuring crisp and clear visuals for your holographic display. The optical prism is made of K9L glass, which just denotes the type of glass, and it's ideal for creating this sort of holographic effect. Powering the device is a 5-volt, 1-ampere power supply, while the USB Type-C interface allows for easy connectivity and programming of the ESP32 board. The entire setup is housed in a 3D printed base, providing a custom and sturdy enclosure for the components. To enhance its capabilities, the device is equipped with an MPU 6050 sensor. This sensor combines a 3-axis gyroscope and 3-axis accelerometer, allowing for precise motion tracking and orientation data. This feature opens up a wide range of interactive and responsive applications, from gaming to motion-based control systems. We have the power to easily program this device using platform.io, flashing the all-in-one operating system with just a few simple steps. Okay, so I'm just gonna pop open cursor.io, and I already have my platform.io project ready to go. I can just go to the home page here, I can go to projects, and then I can go over to AIO_firmware_PIO. I'll leave the GitHub link in the description below, but I'll go ahead and open this, and it's gonna show this project right here, and it has all the resources and dependencies. And what I can do is I will go ahead and plug in my ESP32 Actually, let's open up a serial monitor first, and this will just show all the debugging information that we have. So all we have to do to get this firmware loaded onto our ESP32 is to click Build, and this is going to take a second, and then we're going to click Upload. Okay, and so we can see that the device is rebooted, and as we navigate through the apps, it will register in the serial terminal. So PC resource is selected, stock app is selected, heartbeat app, anniversary, snake, 2048, etc. From there, the possibilities are really endless. We can extend the software with our own programs or tweak existing ones to fit our needs perfectly. And I actually didn't know this, but you can really have a fully functioning operating system without a keyboard, mouse, or microphone. Using just the gyroscope and accelerometer, you can toggle through menu items. Simply tilt forward for 1 second to enter an app, and then tilt back for 1 second to exit. Pretty cool, right? And there's a whole host of out-of-the-box applications like a handy weather app, a stock market tracker, games like Snake, a holographic clock, fun visuals, and much more. However, I wanted to customize my device further, so I created a red dot display mockup in Photoshop and exported it as a PNG with a resolution of 240 by 240, matching our display's resolution. So we just flashed the firmware, it's working as expected. But now I want to get my own custom image onto this monitor. I want to create a red dot optical sight just by way of example of what you can do. So I'm going to come over to Photoshop, and I've already mocked up this sight here. You can see it's mostly transparent, but it has a white outline, a red dot in the middle, and some guiding indicators right here. So I'm just going to go to Export, Export As. So the screen is 240 by 240, so it's best if we stick to that resolution. So I'm going to export, I'm going to go downloads, I'm going to do red dot sight, and we're going to save that. And then we need to convert that to a file format that is compatible with the firmware that we have. So the documentation said to use the LVGL image converter tool. So I'm going to come over to this, and we're going to go to LVGL version 8, and then we're going to use True Color Alpha, and then we're going to use RGB 565. And then I'm just going to select my image, should be in downloads, red dot sight, and this is going to convert it to a .bin file. So I'm just going to call that final. So red dot sight final .bin. So I'm going to disconnect the ESP32, and then I'm going to grab the SD card. You do that by pulling back the clasp there, and then we're going to put this into micro SD card. And all you have to do is create a directory called images, and then you just put the bin file in there. So let's wait for this to pop up here. I'm going to delete everything else in here for now, and we are just going to open up another Finder window, and in our downloads we're going to go by date, this guy right here. Okay, I didn't quite hit the mark there. Let's throw it into here. Okay, so now we have our directory, and that's really all we have to do. Okay, so I'm going to remove the micro SD card, come back over to cursor. See, we've disconnected, that's fine. I'm gonna put the micro SD card back in here. Okay, I think we're good to go. And I'm gonna power it back on. Okay, we can see we're reconnecting right here. Good, give it a second. Okay, now we should be able to go over to the image app. And there it is. There's our red dot sight right there. So you can see how you could do some fun things with that. This device also has a variant that can render 3D printing schematics, showcasing its versatility. Interestingly, it's also recently been discovered that 7th century painter Vermeer may have used similar technologies to create his masterpieces, inspiring modern artists to replicate his style using optical devices like these.
It's possible that he was more of a tinkerer, more of a geek And in that way, I feel a kinship with him.
While I may not be painting like Vermeer, I have been experimenting with various exotic displays, such as a 1.28-inch round LCD from Waveshare, perfect for custom smartwatch devices. I've even managed to get a 3.5-inch display working with my Raspberry Pi 5, and yes, I've even played a little Doom on it. In a world obsessed with bigger and better, there's something captivating about these tiny, atypical displays. And I believe we've only scratched the surface of their potential. For more interesting emerging tech, check out this next video. Thanks.